guys, for the last week or so, we've been talking about linear functions. We've graphed them, we've written the functions from the graph, and we've used functions in story situations to answer real-world questions. So what we're going to do now is we're going to take that real-world situation, and now we are going to write the function from it. Yesterday, we were using the equations that they gave us about real-world situations. Today, we're making our own equations. So, first let's talk slope and y-intercepts. Now, slope and y-intercepts, we know what they mean algebraically. Slope is the ratio of change in y to change in x, rise over run. It's a measurement of the steepness of a line. But when we're talking about a story situation, a real-world problem, slope describes any rate of change. Now that slope is going to describe y's per x. It's going to be described in that order. Okay, you're going to hear y's per x or y's for every or for each x. You're going to hear phrases along those lines. That's what we're looking for. We're looking for words like per, each, every, things like that. Now, where have we seen those before? Y's per x. Where have we seen that phrase before? Sorry? Ratios and proportions. Okay, now the key was with proportions, what did the graph of a proportion look like? Straight line through the origin. Now the functions we're going to be dealing with are going to be straight lines. They won't necessarily be through the origin though. They will be straight lines. Every single one that we're going to work with right now will be a straight line, but they're not all going to be through the origin. They might have different y-intercepts. Okay, the y-intercept, we know algebraically, is the point 0b where the function crosses the y-axis. So when we have y equals mx plus b, that b is the y value where the function crosses the y-axis. But in a story situation, it's our starting point. It's how many y's when the x value is 0. So if we want to make an algebraic equation based on a story, we want to make an algebraic function, a linear xy function based on a story problem, we're going to need to talk about slope and y-intercepts. But look at the descriptors. What do both of those descriptors for slope and y-intercepts have in common? What do they both talk about? They both talk about y's and x's. So before we can get to talking about slope and y-intercepts, if we have a story problem and we want to write a function, the very first thing we need to do before anything else at all is we need to clearly define x and y. Okay, we need to say x equals blank. And y equals blank. Okay, we need to say exactly what those are. We cannot be unclear. We cannot be, bless you, we cannot be ambiguous about this. We need to be very, very clear about what x and y mean. Okay, we can't just say x equals time and y equals money. Well, x could equal time working and y could equal money earned, or x could equal time renting a boat, and y could be money spent on that boat. Okay, so it could be either way. It could be money that you're bringing in or money that you're losing. We need to be very, very clear about what it is. Now, when we define them, though, when we talk about what x and y are going to be, Okay, there's something very, very important. Okay, you're going to look at the story, and you're going to see that there's two things that are changing. And you'll be able to tell that those are your x and your y. But the catch is, once we know what the two quantities are, the two things that are changing, we need to decide which one's x and which one's y. X is the input. Okay, it's the cause. And y is the output or the effect. Okay, so y is what's happening, and x is what's causing it to happen. Okay, so in the story about you're working for a certain number of hours and you're getting a certain amount of money, the money that you're getting is going to be the y. That's the result. And the cause is the hours that you work. And that's what it comes down to, deciding which one's x and which one's y. Well, once we figured out what x and y are, everything else kind of falls into place. Okay, because then we can identify slope and y-intercept. And once we have what x and y represent, and we have our slope and our y-intercept, we can substitute into y equals mx plus b. Okay, so the first thing that needs to happen before anything else, we need to clearly define x and y. X and y tell us what everything else is going to be. X is the input, y is the output. Then we identify our slope and our y-intercept. Now remember, slope is the rate of change. Anything where you see the word per or for every or each, that's going to indicate what your slope will be. Your y-intercept is your starting point. That's what you have, how many y's you have when you have 0 x's. Okay, so before the problem actually starts, at the very, very beginning, how many y's do you have? Once you have the slope and the y-intercept, and you have what x and y represent, you're going to substitute them into the formula, into y equals mx plus b. Okay? So, let's take a look at these examples. Okay, so first off, we have a tree was 4 feet tall when it was planted. It grows 2 feet each year. Write a linear function that gives the tree's height in terms of years after it was planted. How tall will it be after 6 years? Now, we'll come back to the 6 years. Come back to that part. First, we need to write a linear function. Okay, when you see the phrase, write a linear function, that basically indicates that you're going to be dealing with y equals mx plus b. Write a linear function basically says that's what you're going to have. Okay, yes. Okay, hold on. Okay, and that's the big thing, guys. We don't want to jump the gun. We don't want to fire through and say, okay, this is what the function is, and then go from there. We need to develop the habits of thinking about the story first. And defining those variables, it has to happen before we can write that equation. Because truthfully, we could write two different equations here, depending on how we define x and y. If we flip-flop them, we would have a totally different equation, which is possible, but it might not be very helpful for us. What we want to do before anything else is define x and y. Okay, the two things in this story that are changing, that has to be what happens first. And when I'm checking your tests and looking at your homework, I'm going to be looking for that. I'm going to be looking for whether or not you defined your variables. Now, the two things in this story that are changing are years and feet. The height of the tree and how many years have passed. Well, which one of those sounds more like a cause and which one sounds more like an effect? Say that again? It's actually going to be the other way around. Okay? The tree's growing as a result of time passing. The more time passing is what's causing that tree to grow. The growth of the tree is not causing the world to spin. It's not causing time to pass. Okay? So time, or years, since planting, That's going to be my x. And my y is going to be the height of the tree in feet. We want to clearly define what x and y are. Because, guys, once we do that, everything else sort of falls into place. Okay, I'm looking for a slope and a y-intercept. I'm looking for a rate of change and a starting point. Well, when it was planted, that sounds like a starting point. So that sounds like a b, a y-intercept. And that y-intercept is 4 feet. When it was planted, before any time passed, it's 4 feet tall. Okay? Now, as time passes, it grows a little bit each year. That's a slope. That's a rate of change. 2 feet per year. So now, I have what my x and y are. I have b and I have m. We can say y equals 2x plus b. And that is my linear function. Now, I can use that linear function to do two things. I can find the height of the tree at any number of years, and I can find how many years it would take to reach any height. All I need is a value. Well, they've said they want to know how tall is the tree after 6 years. 6 years. That's a value of x. That's its time. It's years since planting. So they want to know what happens when x equals 6. What will y be? Well, we'll take that 6 and sub it in place of x. And we'll have y equals 2 times 6, I said plus b. Y equals 2x plus 4. So that means y equals 2 times 6 plus 4. Okay, I got to make sure we don't forget that b equals 4 here. Okay, so 2 times 6 is 12 plus 4, which means y equals 16. Now, that's not our final answer. The question was asked with a complete sentence, so we should answer it with a complete sentence. And when you're dealing with the linear functions, it's a good idea to include both the x and the y value. So we can say 6 years after the planting, or after planting, the tree will be 16 feet tall. Six years after the planting, the tree will be 16 feet tall. And there we go. I'm working on it. All right, let's look at number 2. Billy could only do 6 push-ups before he began his training program. At the end of each day, he was able to do 2 more push-ups than the day before. Write an equation that can be used to find how many push-ups Billy can do after X days of training. How long until Billy can do 50 push-ups? So, write an equation that can be used to find how many push-ups Billy can do after X days of training. They're asking us to write a 2-variable linear equation. What we need to do is define what x and y are. Now, we kind of have one of those, okay? And if we read this story carefully, they'll tell us what they are. We want to know how many push-ups based on days of training. So our x and our y are the push-ups and the days of training. Well, which one feels like a cause and which one's more like an effect? Good. Days of training is the Y, or the X, and push-ups is the Y. So, if I want to sub into Y equals mx plus b, I also need a starting point and a slope. I need a Y-intercept and a rate of change. Okay, the Y-intercept, that's the starting point. That's how many push-ups, in this case, how many push-ups he can do after 0 days of training. Melissa? 6. He can do 6 push-ups after 0 days of training. Okay? What about a rate? Something that puts push-ups and days of training together. Steve? 2. 2 push-ups per day. So I want to use y equals mx plus b. Let's substitute in. And we can say y equals 2x plus 6. And there's our linear function. Y equals 2x plus 6. Okay, now, the second part is how long until Billy can do 50 push-ups. So this 50 push-ups, okay, that's what they're giving us, and we know we need to substitute that in somewhere. We need to think, do I sub that in place of x, or do I sub it in place of y? Well, it's the number of push-ups. And our push-ups, x or y? They're y. So I'll say y equals 50. And I'll take that 50 and I'll substitute it in place of y. So that will give me 50 equals 2x plus 6. And guys, now we have our old friend, the two-step equation. So we get our vertical line. We think about what's happening to x and how do we work backwards to undo it. Well, what is happening to x here? Multiplied by 2 and added 6. So let's work backwards and undo those things. So the last thing he said was they're adding 6. What's the first thing we're going to do? Very good. We'll subtract 6 from both sides. And Q, what's that going to give us? Good. 44 equals 2x. Okay? And then, Callie, what now? Divide both sides by 2. And what do we get? 22 equals x. Now, the question was asked with a complete sentence, so we should answer it with a complete sentence. And we should put both x and y into our answer. So they want to know how long until Billy can do 50 push-ups. It will be 22 days, or excuse me, it will take, sounds a little better, 22 days of training for Billy to be able to do 50 push-ups. It will take 22 days of training for Billy to be able to do 50 push-ups. I think there's something wrong with the period key. Okay? I'm going to take a pause for questions. Okay, so we have a question here about how we know which one's X and which one's Y. And what it comes down to is reading the story very, very carefully and thinking about which one's the cause and which one's the effect. What are you putting in and what are you getting out? Well, if you're putting in time, days of training, you're getting out more push-ups. Okay, if you're putting in time after the tree's been planted, you're getting out a taller tree. So that's what you want to think about, Ab. You want to think about which one's causing the other one to happen. Okay? And sometimes that really takes reading the story a couple of times and really, really thinking about it. It's easy, pretty easy usually, to recognize what two things are changing. Okay? What two quantities are going to have different values. Okay? The years after the planting are going to change and how tall the tree is are going to change. But what we need to think about is which one's causing which to happen. Which came first. Okay? And generally speaking, as a good rule of thumb, if one of your variables is time, it's almost guaranteed that that's going to be x, for the simple reason that we haven't figured out how to control time yet. Okay, time is going to happen regardless. Other things happen because of time. You get taller because of time. You get paid more at your job because you spend more time there. Okay? Excuse me. You have to pay Netflix more money for how long you want to have that service. Okay? Time changes on its own. Other things happen because of time. Okay, so let's look at a couple more. And we don't have a whole lot of time left, so I'll ask you guys, you want to talk about Tammy the hairdresser or Josh remodeling his house? Let's see the hands for Tammy, and let's see the hands for Josh. Well, it looks like Josh was the winner. All right, Josh, read to us about Josh. Okay, so Josh is buying carpet, blah, 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 blah. Let's talk about the two things that are changing in this story. What two quantities are going to change in this story? Price is one, total price is one, and what else? Sorry? Well, it's $50 off, and that $50 is not changing, it's constant. Okay? We're not changing what $50 is. $50 is $50. Alyssa? Very good. The area that he needs the carpet. So the two things in this story are the area of carpet and we're going to spell carpet correctly, and the total cost. Now let's do something a little different this time. Instead of just using x and y, let's pick some different variables. We get to write the equation, so let's pick whatever is going to fit the equation a little better. Well, how about capital A for area? That sounds familiar. And how about a capital C for total cost? All right, now what about a y-intercept and a slope? Okay, so let's go back and let's look for a starting point, and let's look for a rate. Well, the rate might be a little easier to see this time. What's the rate? What's the spot where I have, oh, before I do that, I guess I should be a little more clear about A and C. We should talk about which one's basically Y and which one's basically X. Which one's the cause and which one's the effect? Steve? Very good. Okay? As the area changes, the price changes as a result. Okay? Now, with that in mind, where in the story do I see something about cost per square foot? Hutch? Very good. Okay, so that's my M. That's my slope. $3.50. Okay, that's the cost per square foot. Okay, what about a starting point? Okay, what's the cost before he has any square feet that he needs to buy? And this is tricky. A little bit tricky. What do you think? What do you think, Logan? Awesome. Negative $50. Why negative 50? Excellent. It's $50 off that price. So right away, he's already getting 50 bucks free. So when we write our equation, we can say that the total cost is equal to $3.50, or 3.5 times A, minus $50. Okay, we're taking the total cost, the cost of the carpet, minus $50. And that's our equation. Now, they also give us 2,100 square feet. Is that an A or is that a C? That's an A. So we'll take A equals 2,100 square feet, and we'll substitute that in place of A. Now, we're just about out of time, so we're not going to be able to actually do that right now. But we've been through it enough times, you know how to sub values in for variables. Now, guys, before we pack up, just sit and listen. Just sit and listen. Okay. When we're writing this equation, the very first thing that has to happen is we need to define our variables. Define our x and define our y. Then we can go back and find the slope and y-intercept. And then we can sub those into y equals mx plus b. Okay? That'll give us our equation. Once you write your equation, take a step back and look at it. Make sure it makes sense. Okay, 350 times the square feet minus the $50 coupon.